The recent reports of Russia's reverse engineering efforts on a captured M1A1 Abrams tank, one of the most iconic and technologically advanced tanks in the world, has stirred significant concern in military and defense circles. While it is known that Russia has studied various NATO tanks since the beginning of the Ukraine conflict, the focus now on the Abrams highlights the growing importance of advanced military technology in modern warfare. As the war in Ukraine has evolved, so too has the role of military technology, with captured equipment becoming a strategic asset that provides both intelligence and the potential to reverse engineer and adapt for use on the battlefield. The question now arises: should the U.S. be genuinely worried about Russia's reverse engineering of the Abrams? What does this mean for the future of modern tank warfare and the balance of power in the region? The M1A1 Abrams was designed in the 1970s and entered service with the U.S. Army in the 1980s. Since then, it has undergone numerous upgrades to stay relevant in the modern battlefield. With its combination of superior armor, powerful firepower, and robust mobility, the M1A1 has become a cornerstone of the U.S. military's armored capabilities. The tank's most notable features include its composite armor, powered by a gas turbine engine, and a 120mm smoothbore cannon capable of firing a wide range of munitions. The M1A1's armor is a multi-layered composite material made up of various ceramics and metals, designed to protect the tank from the most modern anti-tank weapons. Notably, the U.S. Army's M1A1 is equipped with depleted uranium armor, which gives it unparalleled resistance to kinetic energy rounds and shaped charges. However, for export purposes, including the tanks sent to Ukraine, these DU armor components were removed, and the tanks were fitted with less advanced composite armor, making them more vulnerable to certain threats. The fire control system on the M1A1 is also a key differentiator, designed to provide accurate targeting even while the tank is in motion. This advanced system ensures that the Abrams can engage targets rapidly and effectively, even in the chaos of the battlefield. This capability is one of the reasons why the M1A1 is considered a superior force on the ground. The reverse engineering of captured military equipment has been a long-standing practice in warfare. Historically, the goal of reverse engineering has been to adapt and improve upon foreign technology to gain a competitive edge. In the case of modern military technology, reverse engineering can provide valuable insights into everything from the materials used in armor to the performance of advanced electronic systems and weapon systems. In the case of the M1A1 Abrams, Russia's interest likely lies in understanding the tank's core design features, including its armor composition, fire control systems, and internal mechanics. While many of the most sensitive elements of the Abrams have been removed or simplified for the export version, Russia could still gain valuable intelligence from studying the tank's overall layout, systems, and materials. Even relatively small advancements or insights can have significant strategic implications. For example, Russia may be interested in understanding the design of the M1A1's gas turbine engine. The engine provides the Abrams with its remarkable speed and mobility, allowing it to outmaneuver many adversaries. While the Russian military primarily uses diesel-powered tanks, the engine design of the Abrams could offer valuable lessons in improving Russian tank engines for greater performance. Additionally, the layout of the crew compartment and the internal ergonomics of the tank are areas that could provide insights into improving efficiency in Russian armored vehicles. One of the key concerns for military analysts is the potential for Russia to adapt the Abrams fire control system or its targeting technology. Even without the most advanced sensors and software that are typically found in the U.S. Army's M1A1, the version sent to Ukraine still contains many advanced capabilities. By studying these systems, Russian engineers could gain insights into how to improve their own fire control systems or develop countermeasures to neutralize the effectiveness of NATO tanks. Uralvagonzavod, located in the Ural Mountains, is one of the largest tank manufacturing plants in the world. It has been responsible for producing Russia's iconic T-34 tanks during World War II, as well as the modern T-72, T-80, T-90, and T-14 Armata. The facility has long been at the forefront of Russia's armored vehicle production and serves as a central hub for the study and development of new military technologies. With the captured M1A1 Abrams now in the hands of Russian engineers, the study of the tank could inform Russia's future designs and improvements in armored vehicles. There is a possibility that certain features from the Abrams, such as its suspension system, armor layout, or even the manual loading system, could be incorporated into Russian tanks, improving their battlefield performance. By combining the lessons learned from the M1A1 with their own indigenous designs, Russian engineers may create a more competitive armored vehicle. Additionally, Eurovagonzavod has a history of producing export versions of its tanks, so there is a long-standing interest in understanding the strengths and weaknesses of foreign systems. The capture of NATO equipment, including tanks, artillery, and air defense systems, provides a wealth of data for Russian engineers. In this sense, the reverse engineering of the Abrams is not just about improving the T-90 or T-80. It could be a key stepping stone toward enhancing the next generation of Russian armored vehicles, including the T-14 Armata. While the reverse engineering of the M1A1 Abrams may not immediately give Russia a technological edge on the battlefield, the long-term implications are more significant. Military technology is not only about battlefield performance, it is also about innovation and adaptability. By capturing and reverse engineering advanced NATO systems, Russia can accelerate its own technological development, potentially narrowing the gap between its military capabilities and those of the West. The challenge for Russia lies in the practical application of the knowledge gained from reverse engineering. While it is true that the M1A1 Abrams is a formidable tank, its design and systems are also highly complex and require significant infrastructure and expertise to replicate. Russia will need to invest heavily in research and development to adapt any lessons learned from the Abrams into its own armored vehicle designs. Moreover, reverse engineering is not just about incorporating new technologies into existing models. It is about understanding the broader context of how these technologies function together. For Russia, the challenge may not simply be copying the Abrams, but integrating it into a coherent and competitive armored force that can effectively challenge NATO's technological superiority. While the reverse engineering of the M1A1 Abrams by Russia may not pose an immediate existential threat to NATO's tank superiority, it does highlight vulnerabilities in the U.S. military's approach to technology export and military aid. The export variants of the Abrams, with their reduced capabilities, were designed to prevent the loss of sensitive technologies such as DU armor, advanced targeting systems, and sophisticated communication devices. However, as the conflict in Ukraine drags on and advanced NATO equipment continues to be captured, the concern is that Russia may begin to adapt some of these technologies for their own use. One of the most important aspects of modern warfare is the integration of various technologies across different military platforms. This includes not just tanks, but artillery, air defense systems, and infantry vehicles. For NATO, maintaining technological superiority is crucial to ensuring battlefield success. The continued capture of advanced systems by Russian forces could lead to the development of countermeasures and more effective responses to NATO's military strategies. This situation underscores the importance of future military aid programs and the need for NATO members to continually innovate and adapt to technological advancements. Export policies, including modifications to military equipment sent abroad, must be carefully tailored to prevent adversaries from gleaning too much intelligence from captured systems. Additionally, Ongoing training for military personnel to operate these systems in ways that reduce vulnerabilities should be a priority. So, should the United States be worried about Russia's reverse engineering of the M1A1 Abrams tank? The short answer is no, not in the immediate term. The modifications made to the export version of the Abrams significantly reduce the risk of Russia gaining access to the most sensitive U.S. military technologies. However, the long-term strategic implications cannot be ignored. By continuing to study and adapt captured NATO equipment, Russia may be able to enhance its own military capabilities and develop countermeasures for future conflicts.